Assalamu alaikum, my dear students. How are you? Hope you are fine by the grace of Almighty Allah. Welcome to NIEBS Home School. This is Shahjadi Akter, Assistant Teacher of Science of National Ideal English Version School, Day Shift. Today I am going to take a physics class for class 9 students. My dear students, our today's topic, chapter 2, reading done, page number from 33 to 37, and our lecture number 6 and SW number 5. So let's start our class. Today we will discuss chapter 2, that means motion chapter. Okay, today we will discuss this chapter 2, motion. Now we will start our class. My dear students, we don't have any problems in understanding which object is rest or in motion around us. We observe by our eyes in such a way that when anything moves slightly, we can recognize it very quickly. So we can realize easily what the terms rest and motion mean. My dear students, follow this class with your textbook. So everyone open your textbook and follow this class. We will discuss about rest and motion now. Okay, but in physics it is not sufficient only to realize these terms, rather they have to be well defined. To define them, we can say briefly. Okay, what is rest? When an object does not change its position with respect to time, then it is called rest. My dear students, this is important knowledge based question. Okay, so underline this one. You have to memorize this question answer. What is rest? When an object does not change its position with time, it is called rest. And when what is motion? When an object changes its position with time, it is motion. My dear students, memorize this question answer. Okay, what is rest? When an object does not change its position with respect to time, it is rest. And when an object changes its position with time, this is called motion. Now we will give some example about rest and motion. Now we need to explain the term position properly. In our daily conversation, we use the word position in different ways, but in physics, the word position has a definite meaning. If you are asked what is the position of your school, if your answer is that means bonusri, suppose bonusri, your answer is correct, but the position of your school remains unknown, because to express position we have to know about distance and direction also. Okay, then not only this distance and direction has to be specified. We to express position we have to discuss about distance and direction also. Distance and direction, and not only this distance and direction has to be specified from the position of a reference point. In the case of your school, the gate of your residence was the reference point or origin, and instead of reference gate, the reference point might be a bus stop or a shopping mall, then definitely both the position and the direction would have different values. Okay, but we can specify certainly the position with respect to the new reference point. That is, to specify the position of any object, it has to be mentioned with respect to a reference point also. Okay, to specify the position of any object, it has to be mentioned with respect to a reference point also, and this reference point is not an absolute one. We can conveniently choose any point as reference point or origin. Okay, my dear students, now we will discuss about different types of motion. Different types of motion. We see various types of motion are around us: vibration, rotation, and separations. All these are the examples of different kinds of motion, and probable motions are unlimited, but if we wish, we can talk about some important types of motion separately. At first, we will discuss about linear motion. Okay, this one is very important, my dear students. This we will discuss now: linear motion, circular motion, translational motion, periodic motion, and simple harmonic motion. And you have to memorize this definition also. Okay, this one is important for your question answer. What is linear motion? It is an example of the easiest type of motion. Okay, linear motion is the easiest type of motion, and if anything moves along a straight line, underline this one, This one is question answer also. Okay, you have to memorize this definition. If anything moves along a straight line, then its motion is called a linear motion, and if an object is pushed off on a plane surface, then it moves along a straight line. Okay, and if a ball is allowed to fall from a height, it will fall straight down, so it is also a linear motion. My dear students, this type of this example is very important for MCQ, so memorize this example also. Circular motion. Now we will discuss some circular motion. When a body rotates about a particular point or a line, keeping the distance of the particles of the body unchanged, it is called circular motion. Okay, when a body rotates about a particular point or line, keeping the distance of the particles of the body unchanged, it is called circular motion. Though the motion of electric fans, suppose electric fans and hands of clocks are the examples of circular motion, and our very good wonderful example is circular motion is the moon in the sky. Okay, moon in the sky also, this is also example of circular motion. The moon is not tied by the earth, although it is revolving around the earth, neither it is falling onto the earth's surface. Okay, now come to translational motion. This one is also very important. If an object moves in such a way that all the particles of the object travel the same distance at the same time in the same direction, then its motion is called translational motion. My dear students, this one is also very important, and you have to memorize this definition. What is translational motion? I am repeating, if an object moves in such a way that all the particles of the object travel the same distance at the same time and in the same direction, then this type of motion is called translational motion. Okay, now give an example. Sometimes we see many examples of this type of motion in our surrounding. When something moves in a straight path, then it is its example is very common. But if we do not consider the circular motion of the wheel of a car, then straight advancement of the car is an example of translational motion, and at this time every point of the car will travel the same distance in equal time and in the same direction. My dear students, look at this picture. This is not translational motion because their distance, their time and the direction is not same, and this one is the example of translational motion because all the their distance, their time is equal and same also, direction also same. Okay, this one is translational motion. Now come to periodic motion. My dear students, this type of motion is periodic motion is very important for your exam. Okay, you have to memorize properly this definition. If the motion of a moving object passes repeatedly through a definite point in the same direction, in the same manner, in a definite interval of time, then this type of motion is called periodic motion. Okay, my dear students, memorize properly this definition. And you have already, I know, already learned this type periodic motion in class 6 also. Okay, if the motion of a moving object passes repeatedly through a definite point in the same direction, in the same manner, in a definite interval of time, then this type of motion is called periodic motion. And the vibrational motion of our heart is also periodic, since it vibrates in the same direction and in the same manner after a definite interval of time. The periodic motion may be circular. My dear students, this one is very important for your MCQ. Okay, periodic motion may be circular, hyperbolic or linear. Okay, and circular motion is also a special type of periodic motion. Circular motion is also a special type of periodic motion. My dear students, now come to simple harmonic motion. What is simple harmonic motion? Simple harmonic motion is a special type of periodic motion also, and in case of oscillatory motion, the object oscillates on the both sides of a definite point. Starting from its complete rest position, the object starts moving slowly, and when the objects come to the center, it has the maximum velocity, and then its velocity starts to decrease until it comes to rest. Then it changes its path of motion and moves in the opposite direction. In the opposite direction, when maximum velocity is attained, then its velocity decreases again and it stops its motion completely and starts to repeat its motion slowly again the previous direction. Okay, it continues its motion of this fashion, and this one is, look at this picture, this is the example of simple harmonic motion. Okay, now come to, my dear students, now come to this page, next page, scalar and vector quantities, and this one is also very important. Okay, now we will discuss about scalar and vector quantities. At first we will discuss what is scalar quantities. My dear students, here give some example. Let us read. In the world, we know anything that can be measured is called a quantity. This is the definition of quantity. We have already learned in our previous chapter this. Okay, what is quantity? Anything that can be measured, it is called a quantity. Temperature is a quantity. Okay, because temperature is a quantity, because to measure the temperature can be given a value by measurement. Okay, the temperature of your body is 37 degree centigrade or 98.4 degree Fahrenheit. To express temperature, a single number is sufficient, but there are many quantities which cannot be expressed by a single number completely. With its magnitude, its direction has to be mentioned, or more than one magnitude has to be mentioned, so that they all together can express definitely the magnitude and direction of the quantity. And position is a quantity of this type, because to express position we have to know about distance and magnitude also. Okay, direction and magnitude. To express this only, distance is not sufficient, its direction has to be mentioned too. The quantity which can be expressed only by a single number is called scalar quantity. My dear students, this is the question answer, what is called scalar quantities, and you have to memorize this one properly. Okay, the quantity which can be expressed by a single number, it is called scalar quantity. And example is suppose length, mass, time, temperature, etc. Okay, and what is vector quantity? Vector quantity, the quantity which can be expressed, the quantities for which direction has to be mentioned in addition to its magnitude are called vector quantities. That means the quantity which cannot be expressed only a single number, it is needed to express the direction and magnitude also. This is called vector quantities. And suppose example is force. Okay, force is a vector quantities. Now here is given some example. Okay, besides temperature, example of scalar. And my dear students, this example I said, I am repeating this, the all examples are very important for MCQ. Okay, besides temperature, example of scalar are time, length and mass, and because they can be expressed by a single number only, that's why they are called scalar quantity. And besides the position, you will find the other examples of vector are velocity and force. Okay, that means velocity and force are vector quantities, and you will be introduced with velocity and force in the next chapter. Okay, because they express these quantities, direction to be mentioned along with magnitude. Why force and velocity is vector quantities? Because to express these quantities, direction and magnitude will be mentioned, has to be mentioned. And to differentiate vector quantities from scalar quantities, they are written in bold font, and in book or in computer printing it is easy to write anything, but when we write, to express the vector we have to use a small arrow is used over it. Okay, there, suppose x vector, y vector, a vector, b vector. Okay, we have to use arrow over it, over the quantity. Okay, in this book, physics book, you will be taught, will not involve application of vector, and rest you will be reminded which one is scalar and which one is a vector. My dear students, our today's SW number is 5 and your SW is today's SW number is 5 and your SW is define 5 types of motion. Okay, you have to do these 5 types of motion: linear motion, circular motion, translational motion, periodic motion and simple harmonic motion, and you have to submit this SW on 20 February, that means Saturday. Okay, my dear students, I hope you have understood our today's topic properly. Keep practicing at home and memorize properly all this question answer and practice with writing. Okay, see you in next class. Allah Hafiz.